Hello, we're Team A, Vous, Plait. I'm Vrinda.
I'm Sneha.
And I'm Priyanka. This is our project, a device and app for the prevention of crutch palsy.
Underarm crutches, as shown, are the most widely used crutches in America, but the misuse of these crutches can cause crutch palsy, a type of arm paralysis that results from the damage of the radial nerve. Each nerve has a threshold pressure that it can withstand, which varies from person to person. If the pressure on this nerve exceeds the threshold for an extended period of time, the nerve is in danger of being damaged. Crutch palsy forms when the pressure from the crutch on this nerve exceeds the threshold for the radial nerve. This can result in weakness and loss in sensation in the fingers and arm. Given the importance of crutch palsy, prevention is key.
To start off our mission to prevent crutch palsy, our very first objective was to confirm and identify how nerves are affected by pressure. We designed an experiment with earthworms, which have one ventral nerve cord, to test how their nerve would be affected by exerting various amounts of pressures. Based on our knowledge of how crutch palsy is developed, we expected that the electrical activity within the nerve would decrease as we increase pressure. As we tested worm ventral nerves rather than human radial nerves, only the correlation was used rather than direct translations of the data.
For our earthworm experiment, we used a neuron spiker box to conduct a nerve activity study on the worms. After anesthetizing the worms, we would weigh them and measure their lengths and diameters. We would then begin recording the activity of a nerve by tapping the head of the worm to stimulate activity, as shown in the timeline below. This was done with various weights, allowing us to observe the effects of different pressures applied for a certain amount of time. Using the software to measure the time it took from action to travel from pin 1 to pin 2, we found the velocity of nerve activity for 11 worms.
This graph summarizes the results of the experiment by showing the average velocity of each of the nerves from each trial. There was a significant decrease in the velocity from when no pressure was applied to when the pressure applied was below the body weight, and another significant decrease from when the pressure applied was below the body weight to when the pressure applied was above the body weight. Both of these show how the velocity decreases after the pressure applied increased. Therefore, we can conclude that our hypothesis was correct.
With the earthworm experiment that found a direct relationship between the pressure exerted and nerve strength, our main objective turned to the creation of a device that prevents crutch palsy by limiting pressure exerted on the nerve. The primary goal of the device was to alert the user of their incorrect crutch usage, which would happen when exerted pressure exceeds a threshold.
We used the disc load cell to sense pressure exerted when using a crutch. First, the load cell was connected to an amplifier in order to better read pressures. Wires were then soldered to a Raspberry Pi, which is a single-board mini-computer. Using the coding language Python, the Raspberry Pi was coded to read the values of pressure and return them. Then, a mini LED light was also connected to the Raspberry Pi, and we coded it to blink on and off if a certain pressure threshold was passed.
The device we created was able to accurately sense pressure applied to the load cell and was also able to flash an LED light when it sensed a pressure above the threshold, which can be changed per person using the device. Because these two goals were reached, we can say that the device met our objectives.
In addition to the device, a mobile application was developed. As one of the key issues regarding crutch palsy is the belief that crutches should be used by placing pressure on the underarm. Such an app could reduce those misconceptions by informing the crutch user of the proper use and dangers of underarm crutches.
With the Xcode software, the storyboard shown on the screen, which helped visualize the components, and different application managers such as Google Firebase, we were able to create an iOS mobile app called Crutch.
When you first open Crutch, you are prompted with a screen where you can create an account, as seen to the left. From there, the user can access the home screen seen to the right, which shows values of pressure placed and steps taken, information which would be obtained from the device in future updates. Next, the graph screen leads the user to 3 different charts that can help the user visualize their crutch use by displaying relationships between time and pressure shown here. Additionally, the information screen allows the user to click through information relating to crutch palsy, like a video on crutch use and articles on crutch palsy, allowing the user to obtain credible information. Finally, the settings screen enables the user to update their personal information and log out of the app. The home and graph screens were made for when the device were to be connected to the app and would display information from the crutch. The other pages were made to meet the objectives.
With this said, we succeeded in developing a pressure sensing device that can accurately measure exerted weight and alert the user when the pressure threshold is passed. Additionally, the app exceeded its goals as it included articles to inform the crutch user of misconceptions and incorporated ways the device and app could interconnect, like displaying pressure statistics numerically and graphically. If we were to continue working on the device, we would look for a way to connect the device and app so the home and graph screens work, test our device on real patients, and create a database to analyze crutch patterns for future analysis. In short, we believe that both the app and device have effectively taken measures to prevent crutch palsy.
We want to give a big thank you to everyone on the screen, as we couldn't have done this project without them. Thank you for listening.